An arithmetic sequence is a sequence in which each term after the first is obtained from the previous term by adding a constant. For example, 3, 5, 7, 9, 11 is an arithmetic sequence with 5 terms. The first 4 terms of an arithmetic sequence are 20, 13, 6, and negative 1. What are the next 2 terms? So the common difference here, if we look at this, looks like minus 7, because that's minus 7, that's minus 7, and so on. So the next term will be another negative 7, so that's going to be negative 8, and subtract another 7 to get negative 15. So negative 8 and negative 15 are the next 2 terms. The numbers 2, a, b, c, 14 in that order form an arithmetic sequence with 5 terms. What are the values of a, b, and c? So we have 2a, b, c, and 14. Okay, well, this represents the first term. I'll just call it a. I know it's a little confusing because you got an a here, but a plus d, a plus 2d, a plus 3d, and a plus 4d. So basically what that means is that the first term is a, and this term is a plus 4d. That's basically how you would label an arithmetic sequence. So 14 equals a plus 4d. And since my a is my first term, it's 2 plus 4d. And therefore 12 is 4d, and therefore d is 3. And since d is 3, we can easily figure this out. So this will be 3 more, so a will be 5. This a is not the same as that a. Sorry about that. I know that's a little confusing, but you guys understand. This will be another 3, so that'll be 8. No, sorry, let me label that properly. This b will be 8. And then another 3, this c will be 11. So 5, 8, and 11 are the answers for ABC. The numbers 7, 15, and t are arranged in some unknown order, form an arithmetic sequence with 3 terms. Determine all possible values of t. Okay, so we could have either 7, 15, t. We could have 7, t, 15. We could have 15, 7t, or we could have 15, t, 7. We could have t, 15, 7, or we could have t, 7, 15. So those are the 6 different ways of labeling, or arranging, I should say. So let's do this. So this is a difference of 8. So that would be a difference of 8. That would make t equal 23. This is a difference of minus 8. So therefore, if that's minus 8, t would be negative 1. Well, we'd have to look at this first. 15 to 7 would be minus 8. So we'd have to go minus 8. So that would make t 23. And you guys get the point. So this one, 7 to 15 is 8. So that means you have to divide that by 2, because that's going to cover 2 differences. So 8 divided by 2 is 4. So this is going to be 4. So that would mean that would be 11. And then same thing here. 15 to 7 is 2 differences. So that's 8. But this is getting smaller. So it'd be minus 4. So that's going to be 11 again. And then this one is plus 8. So this one would be plus 8. So we have to start at minus 1. So the possible values for t, I believe we got minus 1, 11, and 23. So just 3 values for t. The numbers r, s, w, x, y, z in that order form an arithmetic sequence with 6 terms. The sequence includes the numbers 4 and 20, with the number 4 appearing before the number 20 in the sequence. Determine the largest value of z minus r and the smallest value of z minus r. R, S, W, X, Y, Z. Okay, so let's make 4 and 20 at opposite ends. If that's the case, then z minus r would be 20 minus 4, which is 16. And I believe that would be the smallest, right? Yeah. Okay, now let's put... well, r I'll keep here, and z I'll put here. I think that would be the other extreme if we put them closest together, I think. Yeah. And therefore, this is an arithmetic sequence, so that's 16. So the next one would be 16 more, so that's going to be 36. And the next one would be 16 more, which is 52. 16 more is 68, and 16 more is 84. So this time z minus r would be 84 minus 4, and that is 80. So 80 and 16 are the answers to this question. Tank A and Tank B are rectangular prisms and are sitting on a flat table. Tank A is 10 by 8 by 6, sitting on one of its 10 by 8 faces. B tank is 5 by 9 by 8, sitting on one of its 5 by 9 faces. Initially, Tank A is full of water and Tank B is empty. The water in Tank A drains out at a constant rate of 4. Tank B fills with water at a constant rate of 4. Tank A begins to drain at the same time that Tank B begins to fill. Determine in how many seconds will Tank B will be exactly 1/3 full. 1/3 full, okay. Well, the volume is Tank B, right? Yeah, 5 times 9 times 8, which is 360. So 1/3 of that is 360 over 3, which is 120. So to fill that, 120, it's filling at a rate of 4, right? So just divide by 4, and that's 30 seconds. So that takes care of part 1. And then part 2, that one talks about determine the depth of water left in Tank A at the instant when Tank B is full. Okay, it's a little bit different here. Tank B is full. Okay, so we just figured out the volume was 360, and if we divide that by 4, that's 90. So it takes 90 seconds. So now we turn our attention to Tank A, which is a 10 by 8 by 6, which is 480. And after 90 seconds, if it's the same rate, it'll be 360. So the full volume of Tank A is 480, but it's going to be only 360 full. So we got to figure out. Well, actually, no, it's draining. It's draining. Tank A is the one that's draining out. Okay, so it starts with 480, and it's going to drain out 360. So 480 minus 360 is how much is left. So 120 is left. So basically what they're saying is that when there's 120, what is the unit here? Centimeters cubed of water remaining, what is the height? Okay, so whatever the height is, I actually don't know, but let's say it's somewhere around here. So the height, we'll just call it h. So it's going to be a 10 times 8 times h, and that's going to equal 120. Yeah, so that means this is 80, h is 120, so therefore h would be 120 over 80, and that, I believe, is 1.5. 1.5 is the height that they're asking for. And then part C, at one instant, the depth of water in Tank A is equal to the depth of water in Tank B. Determine this depth. All right, so let's think about this. So for Tank B, since it's filling, 5 times 9 times the height, because it's filling, so it's going up, so I'm not sure what the height is. And that is basically the volume at some point. And that's going to equal how much is remaining in Tank A, because remember, Tank A is draining. So it's 480 for the total, and then you're going to subtract from it how much it drains, which is 10 times 8 times h. Yeah, because the depths are equal, right? Yeah, the depths are equal, so which is essentially the same as the height. Okay, so I think this is the math. 45h would be 480 minus 80h, which would be 125h is 480, and therefore h is 480 over 125, and therefore h is 3.84 centimeters. 3.84 centimeters would be the depth when they are both equal in depth. Tank C is a rectangular prism that is 31 by 4 by 4. Tank C sits on the flat table on one of its 31 by 4 faces. Tank D is in the shape of an inverted square-based pyramid. As shown, it is supported so that its square base is parallel to the flat table and its vertex touches the flat table. The height of tank D is 10 and the side length of the square base is 20. Initially, tank C is full of water. Tank D is empty. Tank D begins filling with a rate of 1. 2 seconds after tank D begins to fill, tank C begins to drain at a constant rate of 2. At one instant, the volume of water in tank C is equal to the volume of water in tank D. Determine the depth of the water in tank D at that instant. All right. So let's talk about this first. The volume is 1/3 a squared h, and did they give us that? I think they gave us that, and I don't think I included it, but this was given, by the way, in the question, just in case you're wondering. Now, in our case, the question has told me that my a is 20, which is the base of the square, and the height they have also told me is 10. So we can easily calculate that. That wouldn't be a problem. And then the rate of filling is 1 centimeter cubed per second. And initially, this is tank C is full, and initially tank D is empty, I believe. Okay. So after 2 seconds is when this starts. All right. So first, let me just figure out the volume here, because that's pretty straightforward. That's going to be 31 times 4 times 4, and that's 496. So after 2 seconds, so it starts with T for the tank D, and 2 seconds after T starts to fill, right? 2 seconds after T starts to fill, yeah. Okay, so if that's T, then for this guy, tank C, it'll be T minus 2, whatever T is. So this tank C is already starting full, but it's going to drain. So it's going to drain. Did they tell me how much it drains by? Was there some rate here? Here it is. It drains at 2 centimeters cubed per second. Okay, so that means this R is 2. So it'll be T minus 2 times 2. And on this side, it's pretty straightforward. It's just T times this 1. And then these are equal. Yeah. At some instant, the volume of water is equal to the volume of water in tank D, tank C and tank D. Okay, so I'm pretty sure that is the math. And if so, let's solve this. So be 496 minus 2t plus 4 is t. So therefore 3t would be 500, and therefore t would be 500 over 3. So that's the time. So what we have to figure out actually is the depth, right? Yeah, the depth. Okay, so the depth is going to involve looking at that diagram again. So if you look at the diagram again, this sort of represents what we're talking about. As it's filling, we want that depth. So what we were going to do is look at this formula, which is 1/3 a squared h, and look at this diagram right here. So the volume is going to be 1/3, and since the dimensions of the original were 20 and 10 for the side length and the height, there's a ratio of 2 to 1. So that's why if this is D, this is going to be 2D. Same ratio, 2 to 1. So the side length is 2D, so sub that in, and the height is D. And that's pretty much how you calculate this. So this would be 4 over 3D cubed, I believe. And that 4 over 3D cubed is going to be this time times the rate, which you remember is 1. And that will calculate the D. So this would be 500 over 4. And that's what? 125. D3 is 125. And therefore D would be 5. The integers a, b, and c and d are equal to one of 1, 2, 3, 4, 5, 6, 7, 8, 9. The integer p equals the product a, b, c, d. That is, p is equal to a times b times c times d. Determine whether or not p can be a multiple of 216. Okay, well, let's look at 216. What is 216 in terms of its prime factors? I believe it's 2 times 2 times 2 times 3 times 3 times 3. I think. Yeah. So can it ever look like this with A, B, C, D being chosen from that? And they're not distinct because it is possible that 2 or more can have the same value. Okay. All right, let's see. Can we get 4 numbers? 4 numbers. 1, 2, 3, 4. And they're going to be multiplied. I think so. Just have that 2 alone, combine these guys, have that 3 alone, and combine those 2, and there you go. So you're taking this 2, this 4, this 3, and this 9, and you can get 216. So the answer to this is yes. Okay, let's move on to B. Determine whether P can be 2000. 2000. Okay, so same kind of story. Let's do a let's do a prime factorization. So it'll be 2 times 2 times 2 times 2 times 5 times 5 times 5. Okay, now let's see if we can get this as 4 numbers from that list up there. Well, this is 16, so I can't use 16 because it's got to be a number from 1 to 9. The 5s are fine, and they can be same because remember, 2 or more can have the same value. I don't think so. So even if we made one of these, like if we just combined these guys and put an 8, and kept this 5 and kept this 5, this would become a 10, and 10's not allowed since the only numbers that are allowed are between 1 and 9. So no matter how you kind of fiddle with this, the answer will be no. We won't be able to get it into the format that they want. All right. C says, determine the number of possible different values of P that are divisible by 128 but are not divisible by 1024. So P is divisible by 128, but P is not divisible by 1024. So 128 is 2 to the power of 7, right? And 1024 is 2 to the power of 10. So that means that P can be divisible by 2 to the power of 7, 2 to the power of 8, 2 to the power of 9, but not 2 to the power of 10 or higher. Yeah. Okay, let's see what we get here. So, since P is equal to A times B times C times D, that basically means that A has a certain number of factors of 2. And let's just use the letter capital A. And then B has capital B factors of 2, and C has capital C, and D will just say capital D, factors of 2. Now, when you multiply them together, as we have here, the factors would be exponents, and they would add. So that means that A plus B plus C plus D has got to be less than 9, like that, and it's got to be at least 7. because it has to be divisible by 2 to the power 7. So for example, let's say you had a as 2 to the power of, let's say 3, and b as 2 to the power of 3, and c as 2 to the power of 2, and d is 2 to the power of 1. This, if you multiply it all together, is 2 to the power of 1, 2, 3, 4, 5, 6, 7, 8, 9. And that's fine because it's acceptable. So that's what we have to kind of look at. That we've got to look at all the cases of this scenario. Okay, so let's do that one by one. First, let's look at if a plus b plus c plus d equals 9. And then we'll look at 8, and then we'll look at 7. All right, if a plus b plus c plus d, a plus b plus c plus d is 9, that means we got a few scenarios. We could have a 3, we can have a 3, 3, 3, 0 scenario, where a is 3, b is 3, c is 3, and d is 0 in terms of their number of factors of 2. We can have a 3, 3, 2, 1 scenario, or we can have a 3, 2, 2, 2 scenario, I believe. Okay, let's go through these. So that means this is the small a's would be, the small a would be equal to b equal to c, and that would be 2 to the power of 3. That's 8. And then d, since it has no power of 2, and it's a digit between somewhere between 1 and 9 inclusive, it could be either 1, 3, 5, 7, or 9. And therefore p, if you multiply them all together, would be either 2 to the power of 9, or it would be 3 times 2 to the power of 9, or 5 times 2 to the power of 9, or 7 times 2 to the power of 9, or 9 times 2 to the power of 9. So therefore that's 5 values. So the number of values I'll put here, 5. And then now this question just kind of repeats like this again and again. So for this guy here, we just did this. This is going to be a is equal to b is equal to 2 to the power of 3, which is 8. And then c is 2 to the power of 2, which is 4. And d again is either 1, oh wait, d is a 2 to, has a 1 factor of 2. So it can be either 2 to the power of 1, which is 2, or what other could it be? 1 factor of 2. 6. It could be either 2 or 6. Yeah. So that means p is going to be either 2 to the power of 9 or 3 times 2 to the power of 9. Let me just double check this. Yeah. So that means there's just 2 values. Okay, so just 2 values. Okay. Moving right along, we get to the next one, which is this guy. And that means a is 2 to the power of 3, which is 8. And b is equal to c is equal to d, which is 2 to the power of 2, which is 4. So for them, when we combine them, it's just 2 to the power of 9 is the only choice, only possible value. So there's this one value there. So we have a grand total so far of 8. But that's just this guy. Remember, we have to do a plus b plus c plus d is equal to 8. And then we also have to do a plus b plus c plus d equal to 7. And that will be very similar to what I've already done. So I'm not going to do everything. I'm just going to do a few of them. Yeah, I'm just going to do a few of them. I'll do the 3, 3, 2, 0. And then here I'll do a 3, 3, 1, 0. I'll list them. There's 3, 3, 1, 1, 3, 2, 2, 1, and 2, 2, 2, 2. And then for this guy, there's 3, 2, 2, 0, 3, 2, 1, 1, and 2, 2, 2, 1. So for this one and this one, let's see what we get. For this one, that means a would be equal to b would be equal to 2 to the power of 3, which is 8, and c would be equal to 2 to the power of 2, which is 4. Therefore, my d would be anywhere from 1, 3, 5, 7, or 9. The values for p are 2 to the power of 8, 3 times 2 to the power of 8, 5 times 2 to the power of 8, 7 times 2 to the power of 8, or 9 times 2 to the power of 8. So that's 5. So we got 5 there. Now for these three, I won't do them, but the good news for you is that they have no new values of p. Whatever values of p you get are I just realized that they want different values. So if they want different values, we only have to look at unique values. So since this is already the same here, and this has already been included here, this actually doesn't count. And same thing, this 2 to the 9 have already been included there, so that doesn't count. So this is the only sort of 5 unique that we get from this scenario. Here, same thing, we get 5 unique, and these ones will give you values of p, but they'll be the same as these guys. So that's actually very important. And then for this last one, let's see here. The 3, 3, 1, 0, a will be equal to b, which is 2 to the power of 3, which is 8. And then c is 2 to the power of 1, which is just 2. And then d, of course, is either 1, 3, wait, hold on. C actually could be 6 also. Yeah, it could also be 6, since 6 has 1 power of 2. And then D is going to be either 1, 3, 5, 7, or 9. So now this will give you a few p's. 2 to the power of 7, 3 times 2 to the power of 7, 5 times 2 to the power of 7, 7 times 2 to the power of 7, 9 times 2 to the power of 7. And then when you start putting 6 in, it would give you, let's see here, and I'm just going to list the unique ones. 15 times 2 to the power of 7, 21 times 2 to the power of 7, and 27 times 2 to the power of 7. So this is 8. So there's 8 the unique ones. And then these three, when you calculate them, they will give you no new values of p, no unique ones. So the grand total is this 5, and this 8. So that's 18 unique values of p that match the criteria of the question.